Lesson 2.6 is all about percents and mixture problem solving. So quite a few story problems within this lesson. The first set of problems for the first goal, which is basically to use that percent equation, which we'll rewrite onto our paper in just a moment. Those examples are all within that PowerPoint, which is a PDF file that you can find on Canvas. So all of those early on examples within lesson 2.6 have already been worked out. They're all posted, so please make sure you check those out on Canvas. We're going to get started with the problems with percents that involve discount, markups, and finding percent change, or dealing with a percent change and finding a new amount or even the starting amount. So the first few examples, in pretty much all of these cases, are going to be using that percent equation that I mentioned. So this percent equation in general is A equals P times W, where A is the part, and a lot of times it's identified by looking for the word is. Then we have the percent, which is in decimal form. And then we have the whole, which a lot of times you can look for the word of. So that is our percent equation, this A equals P times W. So that is what we're going to want to keep in mind as we move through all of these examples we're going to see in just a moment. So the first example we're going to take a look at is question number 12 out of the textbook. And in this problem, it tells us that we're clearing out a brand of discontinued power tools. This home supply store marks down the tools by 25%. If the sale price for a cordless power drill is $82.35, what was the original price? So going through this problem, the amount that it was marked down by, we can think of that as the discount. So the discount is 25%. The sale price of this cordless power drill, so the sale price is $82.35, and we are trying to find the original price. So we don't know that information. One thing to keep in mind with a discount, so if we're getting a 25% discount, the way I actually like to model this is using that bar model. So with a bar model, if we sketch this out, on one end we'd have 0%, the other end would be 100%. 0% would mean you're at $0. We don't know what the 100% price is. We don't know what the original price is, so this is our unknown value. We do know that we took off 25% of the price, though. So if we took off 25% of the price, how much are we left with paying? We're left with paying 75% of the original price after that 25% discount. So that 75% is what we're going to use to go through and solve this problem using, again, that percent equation. This, again, too, if we match up with the price that they give us here, $82.35 would be on the top to complete our bar model. So that 75% discount matches with this $82.35. And again, this is after the 25% was taken off. You're left paying 75% of the original price. So we'll make a note of that. Oops, we're paying 75% of the original price. So setting up this problem now, again, using our percent equation, A equals P times W. The part is the sale price, so we're going to write $82.35 in that spot. The percent, we're not going to use 25% because, again, the 25% represents the amount that it was discounted. We're looking at the sale price as the part. So we're looking at, well, how much is that percent that's left that represents the sale price? And it was 75%. You're paying 75% of the original price. So we're going to use 0.75, and then we don't know what W is. We're trying to find the whole. The next step here would be to divide. We've got my paper here. So once we get to this point, we're going to divide both sides by 0.75, and then we're going to find our final answer. So after we do this division, we should calculate that it's $109.80 is the original price. And again, this makes sense because if you're paying a sale price, the original price should be more. Question number 14 out of the textbook is a very similar situation as the last problem. So this time we're going to be dealing with a markup price, though. So something is going to be more expensive than what we started with. Or I'm sorry, excuse me, we're trying to find the wholesale price, so it's actually going to be cheaper. So the markup for this problem, we're talking about a seafood restaurant. So an oceanside restaurant prices its fresh fish using a 90% markup over its cost. If it sells fresh red snapper for $19.95, what was the restaurant's cost for the fish? So just like the last problem, we'll write out some of that key information. So we know that the markup percent was 90%. The selling price, which would be that markup price, is $19.95. And then we are trying to find the cost or the wholesale price for this fish that the restaurant's selling. So one thing to keep in mind when we're dealing with markups, the markup or selling price, so your markup or selling price is 100% of the cost / wholesale price plus the markup percent, because you're taking whatever the original cost is and marking it up that additional percentage. So we're doing 100% of the original price plus the 90% markup amount. So your total increase in the price, or the percent you'd want to do in this problem, would be 190%. So that's what we're going to use when we go through and do this problem. So we're going to be doing, again, A equals P times W, so using that percent equation, which is what you used with those basic percent problems earlier in the chapter, or this lesson that's introduced. Finding the part, finding the whole, finding the percent. We use this percent equation. So now we're going to plug in our information that we know. So the part is the selling price, this $19.95. The percent is this 190%, because again, that selling price is 100% plus that 90% amount to get to that selling price. So we're going to use 1.90 or just 1.9. You don't have to necessarily have 0 on there. And again, we don't know what the whole is. We don't know what that wholesale price was. Just like the previous problem, we're going to go through and divide both sides by what's in front of our variable, since that's being multiplied there. And then we're going to find that the wholesale price is $10.50. Which, again, always make sure that it makes sense in the context of the situation. This does make sense because a wholesale price should be cheaper because the restaurant's going to mark it up so that they can make a profit off of it. So that's an example of a markup question. For this next example, we'll be looking at percent change. So these percent change problems talks either about an increase or a decrease. Sometimes you have to find that increase or decrease percentage. Sometimes you have to start the starting population, or in this example, or sometimes you're finding the new amount after that percent change happened. So this is question 20 out of the book, and this one's talking about a population increase. So according to the U.S. Census Bureau, the population of the Palm Coast metro area in Florida increased by 84% to 92,000 people between 2000 and 2010. What was the population of the Palm Coast metro area in 2000? So writing down again that key information, we said that the increase was 84%, the new amount of people were 92,000 people, and we are trying to find what the starting population was. So this is very similar to the markup problem. So we can just make a little note of that this is going to be just kind of like how we solved this last one. So similar to markup problems. And with that being said, that means you started with whatever the value was to start with, that's 100%, plus the amount of the increase. So the percent we're going to use in this problem is 184%. Because you have your 100%, the starting amount, plus whatever you increased it by 84% in this case, to get a total increase of 184%. So when we do this, again, we can use the percent times the whole, so percent times the whole times, equals the part. So A equals P times W. And we know that the new amount was 92,000 people. So this is going to be, again, the part. That's where we ended up. So 92,000 is going to be plugged in over on the left-hand side. The percent's going to be 1.84. And then the whole is what we're trying to find. We're trying to find that starting amount. So now when we go through this, we're going to solve it just like the previous problem by dividing. And we find out that the starting population was 50,000 people. Which again makes sense, because if there was an increase in the population, where you started should be less than the new amount. For the next percent change problem, we're going to look at a question where our information is decreased by a certain percent. So in this case, question 22 out of the textbook, we have daycare enrollment that we're looking at. And following an investigation into finance fraud, this daycare center's enrollment decreased by 30% to 56 students, So what was the daycare center's enrollment before the investigation? I'm struggling with speaking today, sorry. So looking back again at that information and rewriting down those key facts, the population for the daycare was decreased by 30%. The ending amount was 56 students. What was the initial enrollment amount? So this goes back to basically that percent discount. And if we want to, again, it's not a bad idea to just visually see what's happening in this situation. So again, we can sketch out that bar model to help us visualize the percentages. So starting would be 0%. That would mean 0 students there. Then 100%, which is what we don't know. We don't know what this starting value is, because that's what we're trying to find. What is this initial 100% amount? It was decreased by 30%. So we took away 30%, which means we have 70% left of whatever the enrollment is, which they tell us that the ending amount was 56. So this 100% value should be more than 56. And the 70% is what we're going to use when we go through and solve this problem using the percent equation. Because again, you're left with 70% of the original amount after there was a 30% decrease. So A equals P times W. So the part is where you ended up, so we got 56 equal to our percent, which we're going to use 70%, but wrote as a decimal, so 0.70 or 0.7 times W, because again, we don't know what the original amount is. And then we go through and solve this. So just like all the other ones, we're going to divide by 0.70. And then we find out that the initial enrollment, there were 80 students. And that's an example of a percent change problem. The next problem we're going to take a look at is actually number 29 of the book, and I wanted to take a look at this one because it has to do with those acid mixtures, or sometimes it's an alcohol solution, and they're all set up basically the same way. So I skipped to question 29 just so we could take a look at that, and then we'll actually go back to question 28 to look at a problem that is, again, very similar, but it has to do with salad dressings. So in this case, we have a pure water mixture that we're going to combine with this 1.5 cups of 30% acid solution. And we're trying to dilute this to a 2% acid solution by, again, adding that pure water to this mixture. One thing to keep in mind for these acid or alcohol problems is that pure water is considered 0%, the acidic concentration of that, and the concentration of pure acid would be 100%. So that is going to come up from time to time. So if you have one of these acid questions, pure water, 0% concentration, and then pure acid would then be 100%. This here that I have wrote out is the formula that we're going to use every time we do one of these questions. It's actually going to be very similar to our question with using the salad dressings. So basically what this says is we're going to take the first percent, times it by the amount of that first item, plus the second percent of the amount, second item, whatever that might be, so multiply that together, equals the final percent times the total amount. So in this problem, we're going to let C equal the cups of pure water that's needed, because again, that's what we're trying to find. Cups of pure water. So our total solution, or our total amount, will be C plus 1.5, because again, C is the cups of water, and we already know we're going to be mixing 1.5 cups of that 30% solution with however many cups of water. So this is going to be the total amount. So now when we go through and plug this information in, using again our variables that we've listed here, percent 1 is actually 0%. So we're going to have 0 or 0.0, however you want to write it, or 0.0, but it's just 0. So we're going to have 0 times the amount of 1, which is C, because we don't know what that is. Percent 2 is 30%, so we're going to write that as a decimal, just like we did when we solved the percent equation problems. Times the amount of 2, which is 1.5 cups, because it tells us again that 1.5 cups are being mixed. And then we're going to set that equal to, again, we're trying to get a 2%, so that's the final percent we're trying to get to. And then the total amount is C plus 1.5. Whatever C is plus the 1.5 cups is going to be the total amount that you're going to have of the solution. So now we're going to go through and solve. 0 times C, it would be 0, so this is actually going to go away. 30 hundredths times 1.5 would be 45 hundredths, so we'll have 0.45 equal to, and then over here we're going to have to use the distributive property. So we're going to take the 2 hundredths on the outside and multiply everything on the inside. We'll have 0.02C, sorry, I wrote it backwards on my notes, and then 0.03 after we do the 2 hundredths times the 1.5. Solving this, we're going to subtract the 3 hundredths from both sides. We'll have 42 hundredths equal to 2 hundredths C. Last step is to divide. And we find that 21 cups of pure water are going to be needed in order to dilute the solution down to a 2% acid solution. For this last example, I already have this one wrote out. So this is question 28, and it's about salad dressing, like I mentioned. So a cook needs to mix a regular ranch dressing containing 46% fat with a light ranch dressing containing 26% fat to result in 5 cups of a dressing containing 32% fat. How many cups of each kind of dressing should be mixed? So again, very similar to the acid type of mixture problems, and we're going to actually set it up very similarly. So again, rewriting that information, we have the regular ranch, which is 46% fat, the light ranch, which is 26% fat, and again, this results in 5 cups of 32% fat. So if R we let be regular ranch, then 5 minus R is going to be the amount of light ranch. So again, 5 was the total, minus however many cups of regular ranch is going to leave you with the amount of the light ranch. So that's what we're going to plug in when we use that setup as before, where we have percent of the first item times the amount of the first item, again, R, the percent of the second item times the total of that item, so 5 minus R, equals the percent, the final percent, and the final amount multiplied together. So again, 5 cups. Going through and solving this, we use the distributive property, we'll combine like terms, solve, and then we find out that it's 1.5 cups of regular ranch, which means that you're going to use 3.5 cups of light ranch because you're going to do 5 minus 1.5. So that's just quickly going through that question. All of this is worked out on Canvas, so if you need to take a look at those notes, make sure you do that.